Hello, we're going to measure the speed of light using a microwave. This is going to be our last lab activity for physics. You need a couple things. You need a microwave, you need a plate. A paper plate works better because it doesn't get as hot when it's in the microwave. And you either need to fill the plate completely edge to edge with marshmallows, or you can do it with 2 chocolate bars or a chocolate bar with the smooth side up.
If you don't want to waste all that chocolate, Mr. Kuiper, could you cut a smaller
It's
plate?
It's not gonna.
Could you cut a smaller plate and just put like a small chocolate bar?
It needs to be at least like 8 inches across.
Okay.
But you can eat the chocolate afterwards because you're not gonna melt it completely. Okay. So in your microwave, there's a couple things. You need to take the tray out, and you need to take the little spinny thing out. Set those aside. Probably need washed anyways. Put your chocolate or your plate of marshmallows, either one works, right in the middle. And then you can set the microwave for any amount of time, but you're only going to leave it in there for like 2 or 3 seconds. Okay, so I'm just going to put in for 3 seconds because this microwave will let me do that. If yours won't let you do less than a minute or whatever, just take it out right away. I'm going to hit start. Okay, take a look at this and see if we can. So that probably wasn't quite long enough, so I'm going to try it for a little bit longer. I'm going to try it for maybe 5 seconds this time. Still not seeing any hot spots. So what we're looking for is like a place that this is just from when it melted in my car on the way home from the grocery store.
This whole experiment is invalid.
Well, I'm going to edit all this out. Okay, I'll try it for maybe 10 seconds here. I can feel it's getting warm. Okay. This isn't working as well as I'd hoped. Maybe I shouldn't have used dark chocolate.
Did you get the king size that's fatter?
Maybe I'll see underneath if it's melted. Oh, there's a hot spot there. See, it only melts in like 1 or 2 places, so there's a hot spot there and there, but I was hoping that the top would melt. I'm going to try this one more time here.
These are knives in case you need to catch a predator.
Okay. Oh, that worked. Okay, so this is one big melty spot here. So this is a node. And what I'm going to do is I'm going to try to measure the length of this. Ideally, you can get 2 of them there. I can see that the corner is kind of melty, but not quite. Ideally, you can get 2 of them and kind of measure the distance on them. Okay, so I'm going to get my tape measure out, which I just conveniently remembered was in there. I'm going to measure the size of this melty area, and that is about 2.5 inches.
Are you doing a diameter here?
I'm doing the total diameter.
Okay, thank you.
Okay, so the diameter would be the part where it's not melty to the part where it's not melty again. Okay.
What if it's longer on one side and shorter on another?
I would measure the long side.
Okay.
Okay, and so that was 2.5 inches. So let's go to the. Okay, so what I'm looking for is the microwave is really making a standing wave with microwaves. And so the two edges of the melty spot is the antinode, and the non-melty spots are the nodes. Okay, so this is really half of one wave. So I'm going to say that 1/2 of the wavelength of the microwave is going to be 2.5 inches. Okay, I happen to know that 2.5 inches is going to be about 6 centimeters.
You could probably also originally measure it in centimeters.
Okay, I didn't have a centimeter tape measure.
If you were so inclined.
Okay, so that would mean that the whole wavelength, lambda, has got to be 12 centimeters. Okay, and what we're trying to do is measure the speed of light. So the other part of the speed of light, so C is the frequency of the microwave times the wavelength of the microwave. Okay, well, how do I know the wavelength of the microwave? It's usually written right on it. If I open it up, sometimes it's written right inside. This one says I remember it said on the back of it 2,450 megahertz. Okay, so the frequency is 2,450 megahertz, which is actually probably what most microwaves are. If you can usually look inside or on the back of it maybe, or underneath or something like that. Okay, so you got to do a unit. You got to just make sure that these are in liter meters seconds, right? So this has got to be 0.12 meters, and this is actually a megahertz is actually a million hertz. So this is actually 2,450,000,000 hertz. Okay, so if I multiply 0.12 times 2,450,000,000, I should come up with a number close to the speed of light. Actually, it is going to be this is going to come out to about 2.8. If I work this all out, it's going to come out to about 2.8 times 10 to the 8th meters per second. Sorry, meters per second. Okay, so what I want you to do is a similar experiment to this. You may end up getting one really wide antinode, or you might get two. If you get two, you're going to get a much more accurate measurement where you can just measure end to end and use that as half a wavelength. Okay, if you do it with a plate of marshmallows, it takes significantly less time, only a few seconds for that to happen, not nearly as much time. And then I want you to calculate a percent error as well. So you get it where you can remember percent error is actual minus theoretical over theoretical. Okay, so see how close we can get with that. If it's a total failure, let me know what went wrong. I hope that works. Now I'm going to let my wife eat this chocolate.